Welcome to this explainer. Today, we're diving into something that literally impacts you dozens of times before you've even finished your morning coffee. Seriously, think about it. Every single time Netflix recommends that perfect show to binge, or your bank suddenly flags a weird charge, or even when your phone just unlocks by looking at your face, you are experiencing machine learning in action.
So what does this all mean? How exactly do these everyday apps seem to just read your mind? And they're doing it without an army of humans behind the scenes checking every little detail. Okay, let's dive into this. The secret sauce working behind the scenes is machine learning. It's truly one of the most foundational, absolutely crucial parts of modern artificial intelligence.
Let's break it down into simple terms. Machine learning is basically a method for computers to learn patterns directly from data, and then use those patterns to make predictions. It's kind of like teaching a toddler what a dog is, right? You don't hand a little kid a rigid, written list of rules about snouts and tails. No way. You just point out different dogs until they naturally get the pattern. It's the exact same concept here. If you show a computer system enough examples, it builds its own internal model. That way, it can make highly useful predictions the next time it sees something totally new. And this brilliantly illustrates the massive shift from traditional programming. For decades, traditionally, a person would write highly specific rules, and then the computer applies those rules to the data to spit out the answers. But with machine learning, we fundamentally flip that entire equation on its head. Now, we provide the computer with the data and the answers, and it figures out the rules itself. So instead of a human writing endless, complex rules to try and detect a spam email, we simply train a model by feeding it thousands of examples of spam and thousands of legitimate emails.
So how do we actually go about building one of these models? Well, most projects follow this really fluid 5-step life cycle. First up, you have to gather your raw data. Next, you prepare those examples. You clean and label the data so the machine doesn't get confused. Then comes the actual magic. Step 3, you choose an algorithm and train your model. Fourth, you've got to rigorously test it. You throw completely new examples at it that it has never ever seen before. And finally, step 5, you improve it by tweaking the whole process based on how it performed.
So the crucial point is this. The goal is absolutely not to just memorize the training examples. Think about it. If it just memorized things, it'd be exactly like a student who memorizes an entire practice test but then completely fails the actual exam because, well, the questions changed. The real magic happens when the system actually discovers the underlying patterns that generalize to totally new, unseen situations. It needs to predict the future, not just sit there and remember the past.
Now, to actually achieve this, engineers generally rely on 3 main approaches. The first one is called supervised learning. This is where we use labeled examples to train the system. You are effectively giving it an answer key right off the bat. For instance, if you want to predict real estate trends, you'd feed the system thousands of houses that already have known sale prices. Providing all those answers up front really helps the computer learn the precise relationship between the features, like say square footage, and the final outcome.
Moving on, the second approach is unsupervised learning. And just like it sounds, here we don't give the machine predefined labels or answer keys. Instead, it just looks for hidden structures entirely on its own. A great example of this would be a business taking a massive data set of online shoppers and just letting the machine group those customers by purchasing behavior. Maybe it discovers something crazy, like people buying camping gear also tend to buy high-end espresso beans. It finds these hidden similarities that we humans might never have even thought to look for. Let's move to and see how this builds out into our final flavor of learning, reinforcement learning. This is essentially learning through good old-fashioned trial and error. This approach relies heavily on continuous feedback loops. It's kind of like training a dog with treats, or a software agent trying to master a really complex video game. It tries an action, gets a reward for doing it right, or maybe a penalty for getting it wrong, and it just constantly adjusts its strategy based on those signals.
Now, it's really important to remember these aren't just abstract lab experiments. From checking your local weather forecast to the real-time translation popping up on your social feed to the fraud detection protecting that morning coffee purchase we talked about earlier, machine learning is literally the invisible engine powering your daily life. It supports advanced medical imaging and diagnostics, handles global supply chain forecasting, and yep, it's even the foundation of those massive generative AI systems that are totally dominating the news today. But, and this is a big warning here is the catch. This technology is not magic. A model is really only as useful as the data you feed into it. It is the ultimate real-world example of garbage in, garbage out. Poor data will absolutely, for sure, produce poor results. And on top of that, a model that performs perfectly in a pristine testing environment might still fail spectacularly if the real world unexpectedly changes its patterns.
So,
To sum it all up, machine learning basically takes massive amounts of experience, or data, processes it into a mathematical model, and outputs a highly accurate prediction. But as these models become more and more deeply integrated into our routines, the biggest question really isn't about the math anymore. It's about us. How do we ensure strict human oversight as these models become increasingly powerful? And how do we continually make sure we are defining the right problems for these machines to solve?
Honestly, understanding this technology is the very first step to asking better questions about how it's built and, more importantly, where it belongs in our society. Understand AI, apply AI, lead with AI.